D block is the block between S and P block, where the elements have the valence subshell as D subshell. That means the valence shell or the valence subshell is the D subshell for these elements which comes under the D block. Properties of D block: the elements which fall in the D block, which comes under the D block, are also known as the transition metals. These are transition elements, that means these have the property of the S and some property of the P, so they are known as transition elements, okay, or transition metals. For example, let us look at one element. For better understanding about D block, we'll look at one element. This is scandium, Sc. The atomic number of scandium is 21. It comes after calcium. 21 is the atomic number. When we arrange it in the electronic configuration, it becomes 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and the last one, 21st, it goes to 3d1. So we see that the valence subshell or the last subshell is D. So that is why this element comes under the D block. Now the next one that we have is F block. F block, like I told you, these are the last two rows, and usually this is written below the modern periodic table. These block elements are known as actinides and lanthanides. These are placed below the modern periodic table. The valence electron enters the F orbital. It is the same thing, like how in S block the valence electron goes to the S orbital, in P block it goes to the P orbital, in D block it goes to the D orbital, and in F block it goes to the F orbital. Okay, so when we look at these, we see that our modern periodic table, it is made of S, P, D and F blocks or F regions, and the elements have been arranged in this block according to their electronic configuration, according to the increasing atomic number, and according to their atomic masses also. Now, after the modern periodic table has been made, let us look at the properties of modern periodic table. What are the information that the modern periodic table gives us? There are 7 information that a modern periodic table gives us. Number 1 is information about atomic radius. What is atomic radius? Atomic radius, it is a distance between the center of the nucleus and the valence shell. I think my spelling of center is wrong. So what is atomic radius? If we have any atom wherein we have a nucleus here and we have, suppose, 2 shells, let us take any element, okay. So from the center of the nucleus till the outer shell, valence shell, what is the distance, the radius? This is known as the atomic radius. Now what happens in the modern periodic table? The atomic radius, when we go in a period, in a modern periodic table, we know that there are 7 periods and 18 groups. When we go in a period, starting from left to right, our atomic radius, it decreases. When we move in a group from top to bottom, our atomic radius, it increases. Like example, if you take the period in which we have sodium, these from top to bottom, these are groups, and left to right, these are periods. So we have 7 periods and we have 18 groups, okay, these lines, these columns. So like example, let us take for period number 3, we have sodium. So like I said, atomic radius, what happens? It decreases in a period and increases in a group. So when we go from left to right, that means from sodium will have the highest atomic radius. The radius will be more in sodium. It will decrease in magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. The distance will keep on decreasing. But as we go from top to bottom, let us talk about lithium. The atomic radius of lithium, it will be least, and as we go from top to bottom, one element after the other, then the atomic radius, it increases. For example, they have said sodium, it has an atomic radius of 157, but when we go from left to right, then by the time we reach chlorine, the radius will become small. That means the size of the atom, it decreases, and chlorine will has a atomic radius of 99. But when you go from top to bottom, lithium has 123, but Fr element it has 256. So we see an increase from top to bottom and decrease in left to right. Now the next property of modern periodic table is ionization energy. What is ionization energy? Energy required to make a positive or negative ion. For any element to become stable, it has to take or give electrons. So when taking or giving electrons, it attains a positive or a negative charge. This is known as ion. Now what happens to the ionization energy? Whenever we go in a period from left to right, ionization energy it increases. That means it takes more energy for an element to become positive or negative ion. And when we go from top to bottom, the ionization energy decreases. That means most energy is required in the topmost element, and as we go lower, less energy is required for an element to become an ion. Now the next one is valence electron. What is valence electron? Electron which is present in the outermost subshell, or we call it the outermost electron. When you go in a period, the valence electron it increases. Example, we know valence electron of sodium is 1, magnesium is 2, aluminum is 3. So we see that when we are going sidewise in a period, the valence electron number will increase. But when we go from top to bottom, the valence electron for any group, it will remain the same. Example, elements in 1A group, they have a valency of 1. Elements in 2A group, they have a valency of 2. Elements in 3 will have valency 3. Elements in 4A will have valency 4. So it is like that. Okay. So in group, the valency will remain same as per the group number. Now the next property is valency. That was valence electron. This is valency. Please do not get confused between two. Valency is the number of electron which is gained or lost to follow the octet or the duplet state. Now in a period, the valency will increase from 1A to 4A. When you look at the periodic table, you will understand. The valency will keep on increasing from 1A to 4A. When we go in a group, in the group the valency remains same. 1A group elements will have same valency, 2A group elements will have the same valency. The same thing like I told you about valence electrons. Now in the next video, we shall be doing about electronegativity.